Hello everyone, and welcome to the Object Storage Working Group Asynchronous Kickoff meeting. My name is Alessio, and I am the facilitator for this working group. I'm recording this short video to introduce some of the high-level aspects that we are going to cover. So let's get to it. Object storage is a fundamental part of GitLab. It's our distributed, highly available file storage. With direct upload, workers can intercept incoming file and upload them directly to object storage before the request hits the Rails application. If you are not familiar with direct upload, I encourage you to watch a presentation I made a couple of years ago. The title is Speed Up the Monolith and talks about workers and how we implemented direct upload to object storage. Unfortunately, direct upload cannot be enabled for every incoming file upload in its current state. And this is one of the main problems we are going to cover in this working group. Over the course of the next few slides, I'll go through some of the areas of improvement that we should take into consideration during this working group. Starting from these different aspects of the product, those improvements will contribute to a better object storage experience for customers, users, and contributors, reducing development costs, operation costs, security risk, also making it easier to adopt new features for on-premise installation. Each feature has its own bucket. Because of this, we don't have direct upload enabled everywhere, as each upload requires a custom worker's code. Contributing a new upload requires coding it both in Rails and Go. And each new feature requires a new bucket that requires omnibus and chart support that requires SRE works to provision that new bucket. And provisioning new buckets slow down features adoptions on on-premise installation and also creates a complex first installation experience with 13 buckets at the time of this recording. With one default catch-all bucket, there is no need for omnibus and chart support merge request, no need for custom workers code, and no need for SRE intervention to provision those new buckets. This will give us a faster development and review process, and every on-premise installation will immediately have access to new features without the need to provision the new bucket. Point number 2, code complexity. This picture is a good representation of our object storage code. It all started with Carrier Wave, a gem that provides a simple and extremely flexible way to upload files from Ruby application, and it was a boring solution back then. However, this is no longer our use case, as we upload files from workers in Go. And we had to patch Carrier Wave's internals to support direct upload, giving us a very hard development experience. Our implementation is built on top of third-party framework, where every object storage client is another third-party library. Unfortunately, some of them are unmaintained, and we had to fork them to support our users. With the removal of Carrier Wave and implementing a new generic internal API for uploads, there will be no need for workers' custom code on each upload that, together with the catch-all bucket, will finally allow us to enable direct upload globally. There will be no need for copying file from a temporary bucket to the final bucket, which is the technical details of the current implementation that is causing troubles to users and customers where they are trying to upload large files. And finally, we will be able to rely on officially supported native clients for object storage. Point number 3, supporting both object storage and local storage is a big cost. In the beginning, object storage was only available as GitLab Enterprise Edition feature, so we had to support local storage for the Community Edition. However, local storage is based on the assumption of a shared disk between components, which is only true on a single box installation without HA or with NFS, which we no longer recommend. We also have testing gap on object storage, because workers and an object storage provider are not present on our unit tests, so too much is replaced by a mock implementation, and both CI and local development runs on a shared disk because it's a single machine, often hiding broken implementations until we deploy on an HA environment. The removal of local storage support, shipping MinIO as part of the product as a local object storage provider, will standardize our file storage on a single technology. Reducing the complexity of development will also mitigate security risk, removing an attack vector as we no longer write user-provided files on the application server. Thank you for your time. I'm looking forward to your ideas on this topic, so please take a look at the agenda and write down your items. And I hope to see you in the next working group meeting.